In line with the Europe 2020 strategy, many local authorities made agreements to become energy or climate neutral in the future. However, as well as in Europe, on a national level, the main focus has been on improving buildings, solar panels and wind energy. The field of blue energy remains quite unexploited. The INNERS project aims to make the urban water cycle more sustainable in terms of energy. The project shows the potential of this new source of blue energy and helps to enable the water sector to deal with future challenges, such as diminishing fossil fuel sources in Europe, increasing energy prices, and stricter carbon emission limits. The partners in INNERS started several projects
to work on four main questions. What's the energy potential of the urban water cycle? How to recover heat? How to reduce energy consumption and how to reuse energy. And last, how to make the transition towards a new perspective on the urban water cycle.
Before we started working, we wanted to find out more about the energy potential of the urban water cycle, or in other words, how much is in it? To figure this out, a lot of research was done. One of our findings was that the largest proportion of energy is used to heat water. The amounts of energy needed to treat and supply drinking water and to treat wastewater are equal. Knowing this, our second question was how to recover heat from the urban water cycle. Multiple projects on heat recovery have been implemented. For example, the project of Kirklees Council and Bradford University managed to heat and cool houses by using a stormwater drainage system. Stormwater is transported through an underground heating and cooling system. Thanks to this, heat can be provided during the winter, keeping the houses warm. Then, during the summer, the system will use stormwater again for cooling. In a project of the Water Board Groot Saarland and the municipality of Ralt, thermal energy from purified wastewater is used to heat the nearby swimming pool of Tigenraan. Around 40,000 litres of water per hour is pumped from the wastewater treatment plant to the swimming pool. Here, heat is exchanged between the effluent and the swimming pool water. This is done with a thermal energy transfer system that includes heat pumps. Not only thermal energy was recovered, we also looked at the wastewater treatment process. Here, we asked ourselves the third question: how to reduce the energy consumption and how we can make the step towards mining of blue energy sources. In INNERS, one of these techniques has been tested and implemented at the wastewater treatment plant in Amersfoort. A so-called demon reactor was installed to improve the process of deammonification, which is done to improve wastewater treatment in terms of water quality and energy use. Thanks to the demon reactor, the purified wastewater now contains less nitrogen compared with the old situation, and €38,000 on energy reduction costs were saved. So far for the technical work, our fourth and final question was: how can INNERS support a transition towards a new perspective on the urban water cycle as a system that contains and transports both water and energy? We made a strategy to see how results could be transferred in the best way to our different target groups. Results were communicated in a tailor-made way, meaning short, visual and simple ones for policymakers and more detailed ones for technical specialists. On the website of INNERS, we created an overview of all the projects and the activities of the INNERS partners. A progress bar shows the development of our different projects, and an overview of results can be viewed by everyone.
During the last few years, we worked together with 11 partners from 6 Northwest European countries to improve the energy efficiency of the urban water cycle. The first step has been made and 4 main questions have been answered. However, we hope there's a lot more to come so we can really deal with future challenges. We hope we have inspired you and we invite you to join us in the future.